It's my
Uh,
pleasure.
Start, please.
Yeah, thank you very much for inviting me and for the opportunity to share my research as well as my university. So uh, this is the first time I use this platform for online seminar. So I just would like to confirm with you: are you seeing the full screen or it is a small one? Is my slides moving? Uh,
Yes, we can see your presentation.
Okay, it's full screen, right?
Okay.
Okay, yeah. Thank you. So yeah, I will start with a brief introduction of NTU as well as our school, uh, which is called School of Electrical and Electronic Engineering. Then after that, I will introduce about my my research, which is power electronics, and to showcase some of the project we have collaborated with the industry and how they can help us to decarbonize the society and power a sustainable future. Then the last part, I would also like to share about our PhD program because I'm now in charge of the PhD student in my school. So hopefully there will be opportunities for us to collaborate in terms of PhD supervision or training. So yeah, this is uh, the joint view of our campus. So you see that on the rooftop of many buildings, they are covered by these blue panels. So actually, these are for power generation or electricity generation. These are solar panels which can convert sunlight into electricity. So for the entire campus, we have about 10 megawatt power generation from solar, which provide a sizable amount of clean power to the campus. Then a little bit introduction to where I'm from. So Singapore is located here. It's in Southeast Asia, but geographically it is quite far from Peru, thousands of miles away. So yeah, again, I appreciate the opportunity for organizing this seminar for us to know each other better. So, Nanyang is not an English word. Actually, it is a direct translation from two Chinese characters, which in English refers to the location of Singapore's Southern Ocean. So in Chinese, it's Nanyang. Then you know that Singapore is a small country. So if you zoom in over here, you see the entire country. Actually, it's an island. Then from north to south to north is about 30 kilometers. Then east to west is about 40 kilometers. So basically, within 1 hour driving, you can reach wherever you want on this island. Then our university is a pretty young university. Literally, we were founded in 1981. So at that time, it was a teaching-focused university, and the name was NTI, Nanyang Technological Institute. So the government set up this new university with the purpose of training engineers for to support the development of Singapore. Then 10 years later, we are renamed to NTU, Nanyang Technological University. Then right now we have about 25,000 undergraduate students, 15,000 postgraduate students, 1,600 faculty members. So although we are a young university, we have already established ourselves as one of the leading universities in the world. So in terms of ranking, we are ranked very well in the world. Then for me, I'm from the School of EEE, Electrical and Electronic Engineering, which belongs to the College of Engineering. Then there are 5 schools under COE, College of Engineering. So just now, there's one student studying environmental engineering. So that is a School of Civil and Environmental Engineering. Then we also have chemistry, biotechnology. Then this is our school. We also have mechanical and aerospace engineering, material science, and engineering. Then all the 5 schools are ranked among the top 10 in the world in terms of, this is from QS ranking by subject. Well, for our school, we are probably one of the largest schools in NTU. So we have in total close to 6,000 students. Then among them, we have 3,000 undergraduate students, 2,000 master students, and about 450 PhD students. So we are very well funded by government and industry. So every year we have over 100 million Singapore dollar research funding. And yeah, these are just some figures to showcase our research capabilities and our research strengths in terms of patent filing, in terms of publications. We are doing pretty well. Then, well, in Triple E, in our school, we have 6 research areas. The first one is power engineering. So we study like power systems, smart grid, clean energy, solar, wind, and all this. Then the second area is microelectronics. There are research on semiconductor devices, optoelectronics, as well as photonics. Then the third area is information engineering, studying like AI, artificial intelligence, machine learning, signal processing, NLP, natural language processing. So this is, I would say, one of the hottest research areas. Then we also have circuit and system, integrated circuit design, communication engineering, 5G, 6G, and 6 beyond for future communication, control and instrumentation. This is like robotics, humanoid robotics, as well as autonomous system, autonomous driving. Yeah, so these are the 6 research areas. Then we are, so for all the researchers and students, we are clustered under 14 research centers. So I won't introduce each of them one by one. So I just would like to mention some of the notable research centers. So this is the center where I'm coming from, Center for Power Engineering. Then we also have this satellite research center. So Singapore launched about 7 or 8 small satellites. So all these satellites are designed in our school from this research center. Then we also have this Nanyang Nanofabrication Center N2FC. So this is an in-house clean room which allows us to fabricate semiconductor devices in the school. So this is a lot of investment into this research center, which is a very real facility you don't often see in the university. Then we work very closely with industry. So we have we call it corporate labs and joint labs. So these labs are set up together with companies. So
please, G, you can
yeah.
your presentation is the
my
slide.
research.
Yes.
Hello.
The slide is the number 1. You can change the slide, please.
Oh, it's still number 1.
Yes. Or if you can send me your presentation, I can share with the public.
Yeah. Let me see. I don't know how to. the file is very large, so because it contains video, so I'm not sure whether I can send it out through email.
Yes, you can send me by email and I can share here.
Because there's a limit from our email server, like 20 megabytes, but the file is I don't know why it's not moving the size.
Yes, now is the well.
Maybe I reshare again. How about now? Are you able to see?
Okay.
So
Yes.
now we should add page 9.
Yes, that's nice.
Okay. Thank you. Yeah. So let's continue. Yeah. These are corporate labs. They are set up jointly with companies. So we have the Delta N2 corporate lab. They focus on IoT, cyber physical system. Then we also have one with Continental, focus on smart city transportation. Then this with nanofilm on advanced materials. Then we also have several small scale, we call it joint labs. So the scale of corporate labs is like over 50 million Singapore dollars funding in total. Then joint labs is around 10 million funding. Then this SP Group is Singapore Power, which is the utility company in Singapore. So this is from my research center. Then we also have this N2 Panasonic joint lab. They work on electrical motor design for robotics, for electric vehicles. Then under the Center for Power Engineering, we have 9 faculty members. Then 4 of them working on power system related research, power system planning, operation, stability analysis, control. Then we have 4, including myself, working on power electronics. So this is like for the power converters for like electric vehicles, for wind, solar power conversion. Then we also have another colleague working on electric motors and motor drives. Then I will talk about my own research and to showcase some of the project and how it can help us power a sustainable future using clean energy. So this is my group. My lab is called Laboratory for Electrification and Advanced Power Conversion, or in short, LEAP. We have about 15 researchers. There are PhD students or research fellows, postdoc research fellows. Then this is our lab, some of the facilities which allow us to conduct all the experiment in the lab. Then we focus on 3 research areas. The first one is sort of a microgrid that contains clean energy, solar, wind, battery to power the system instead of using a fossil fuel like natural gas or coal. Then the second area is high efficiency power converter design, how to convert electricity in a very efficient way to minimize the power losses as well as to minimize the dimension, the size of the power converters. This is particularly critical for mobility applications, for electric vehicles, electric aircraft. Then the third area is wireless power transfer. It's like so probably some of you have iPhone, then you know that we are able to charge iPhone without connecting the cable, right? You can just leave it on a charging pad, then the charging can start automatically. So this is this part of the work. Then these are some of the companies we are working very closely. So the first project I would like to share is this microgrid. So we are probably one of the first in the world started this microgrid research back in 2007. Then the idea is that we use a small-scale power system to integrate renewable energy sources like solar, wind, fuel cell, to replace the conventional fossil fuel. Then we proposed the idea we call a hybrid AC/DC microgrid, where you see the traditional AC power grid, as well as the new DC microgrid system, so that we can integrate the renewable in a more efficient way. Then 5 years later, initially we started with a small-scale system, like below 10 kilowatt, 400 volt. Then after that, 5 years later, we received funding from government, and we scale up the system into a multi-bus microgrid rated at 100 kilowatt. Then we also worked very closely with companies. Then we developed a test bed in one of the islands in Singapore. So you see the picture over here. These are the solar panels. Then we also have the wind turbine. We also have the battery to supply the load demand on this island. Previously, the load is supplied by diesel generators, which produce air pollution as well as noise pollution. So the idea is to use clean energy to replace them. So over here I have a short
Renewable Energy Integration Demonstrator Singapore, in short REIDS, aims to be a unique platform for private and public sector stakeholders to showcase their R&D initiatives. It will take place at Semakau Landfill, located 8 kilometers south of Singapore. Semakau Landfill, being the final stage of Singapore's exemplary waste management program, gives a symbolic message to the location of REIDS. REIDS will be the platform to study, evaluate, and validate the demonstration of a broad range of renewable energy sources in the context of their integration and interaction with a physical microgrid, primarily operating off-grid and featuring multi-technology energy storage devices to supply different loads directly connected to the AC/DC hybrid grid. Excess energy produced by the various renewable energy sources will be utilized to produce gas, water, and even to charge an electric vehicle as a mode of transport on the landfill. REIDS is a joint initiative by EDB, NEA, and NTU. The involvement of multinational and local companies will also be a key aspect of REIDS. Industry partners will be able to address global opportunities in the growing renewable and microgrid markets and commercialize energy technologies through Singapore.
Yeah. Then this is the second project. So again, we work with Panasonic, which is a famous company from Japan. So this is a distributed energy storage system. So the idea is that Singapore is transitioning into a decarbonized society where we installed many rooftop solar panels. Then, but the problem of solar generation is that it depends on weather condition, whether you have sun, like at night, there's no generation from solar, right? So this means that the power generation is sort of intermittent, uncontrollable, which is not good from the power grid perspective. So this is the reason why we study this energy storage system to cope with the intermittent generation from solar. So I believe many of you use headset with a function, we call it active noise cancellation, right? So this is the same concept over here. So we use battery to cancel sort of the noise produced by solar PV, so that the power grid will see a very clean and smooth power curve from this renewable generation. So these are the hardware system we installed in the residential buildings in Singapore. Then again, there's a short video so this is a very typical residential blocks in Singapore, high rising, because it's a highly dense city. So on the rooftop there are solar PVs. Then we installed battery at the ground floor at the switch room, to make sure that the power produced delivered to the power grid is smooth. So in the interest of time, I will skip this video. Then the third project collaborated with Lighttown. Lighttown is from Taiwan. They are one of the major suppliers for NVIDIA GPU power supply data servers. Then we work with them to develop this energy router, which is a system that can efficiently integrate PV, battery, as well as the load and the grid. So this is hardware we developed in the lab. So there are you can integrate three-phase AC grid, three-phase AC load, as well as the DC from PV and battery. Then the efficiency of the entire setup is very high. We developed three converters inside. Each of them has a peak efficiency of 99%. So we also developed this graphic user interface, which allows us to monitor all the information, the data in real time, as well as you see this is the system diagram. We can see the PV, how much the power flow from PV, from ESS, from power grid. Then the fourth one I would like to introduce is about wireless charging. So I believe you are pretty familiar with this consumer electronics application for wireless charging, for charging smartphones, for charging electric toothbrush. But there are also other applications, like for healthcare, to charge implanted pacemakers. Then for industrial automation in smart factories, we use wireless charging for mobile robotics, for forklift, and for sure also for EVs, electric vehicles. Especially in the future, we are talking about autonomous driving electric vehicles, right? There are it's driverless, so there's no one to plug in the charging cable to charge the car. So wireless charging is a promising solution for that scenario. Then for this project, we worked with partners from Norway, which is also far away from Singapore, with NTNU, Norwegian University of Science and Technology, with SINTEF, which is Norwegian National Research Center, and Waseda is a company from Sweden. So they developed the first wireless charging system for ships. So it's the challenge is that for these phones and electric toothbrush, the power is very small, right? But for this application, power is huge, like several orders higher than phone charging. Then the problem they were facing is that for this wireless charging, they have to install additional electrical component in the ship in order to pick up the power from the shore side, right? But the weight and the size of the system are too big. So that's why we work together to improve the we call it system power density, to make it small and light. Then we develop. We have many innovations in terms of the optimal design of this transmitter and receiver. So this is an app we developed in MATLAB, which can help us automatically determine the best design of the precision of each winding of the coil, so that you can maximize the coupling coefficient, which is a critical factor to achieve the highest power transfer and efficiency. So this is the 100 kilowatt prototype we developed in the lab. So 100 kilowatt means that in half an hour you can get a Tesla car fully charged, and we managed to achieve a very high efficiency, 98% efficiency. So the last project, also a very exciting project, which is about an electrical aircraft. Probably this is the first one built in Singapore. So this aircraft is fully powered by battery. It's a big research program. We collaborated with researchers from different schools, from different research institutes. Then for my part, we are in charge of the entire power supply, power distribution system on this aircraft. Then in particular, we worked with this company, Eden, to develop an inverter. So the purpose of the inverter is to convert battery power from DC into AC to drive the motor, to drive the propeller. So this is the whole test we just completed like last month. And due to the regulation limitations, we are not allowed to really fly it in the sky. So we have to do this hover test first. So it's like within 5 meters above the ground. But it was a very successful testing, and hopefully next year we will see some big news from regarding this very exciting project. Then so this part is about my own research. If you have any questions, please feel free to ask. Then the last part I would like to share is our PhD program, and we do offer scholarships to international students. So later I'll share more information. So why choose us? Why to study at NTU EEE? Because we are one of the top in the world, because we have the best faculty members. They graduated from MIT, Stanford, Cambridge University, those very top universities in the room. And we provide cutting-edge research facilities. Just now I mentioned we have a clean room, we have a microgrid test bed, we have robotic steps. So these are the highly demanded by the industry. Then we work very closely with companies. So we have joint labs, corporate labs. So you have the opportunity to work with engineers, scientists from companies. So the research problems are actually originated from companies, very practical problems. They are looking for a solution from our students, our faculty members. Then the research areas, just now I mentioned there are 6 research areas, but probably due to the technical issue, you didn't see the slide. It was not moving. So we have power engineering. We study smart grid, electrical propulsion, like the aircraft project, power electronics, renewable energy, and microelectronics. We have semiconductor devices, photonics, optoelectronics. Then we have information engineering. This is about AI, signal processing, machine learning, integrated IC designs, integrated circuit design, 5G, 6G communication, and this is about robotics and autonomous system under control and instrumentation. Then PhD program in NTU typically spans for 4 years. So in the first year, usually students, they need to take courses to lay the foundation, technical foundation for their research. Then in the second year, they are supposed to pass what we call qualifying examination, which is an oral presentation to to the panel members to see that whether the student meet the expectation, whether the student have enough technical foundation to move forward. Then third year and fourth year, they will focus on research, like publishing research results. Then we have this graduate student club to support all the PhD students in the school in terms of research, academic, as well as well-being. We organize many student activities. So even for those who are coming far away from Singapore, then they won't feel alone in the school. We do have many international students. I think that there's one from, most of them are from ASEAN countries like Malaysia, Indonesia, Thailand, but we do have one student from Europe, Albania, and there's one from Canada, but I don't recall that we have students from South America. Hopefully in the future we could have some from your university. Then we have graduated and trained many outstanding PhD students. So here are some examples. These two actually they received both their bachelor's degree and PhD's degree from our school, and recently they joined us as faculty members. Then we also have graduates who are now becoming professors in overseas university. So this Dr. Xu is now with KTH in Sweden, which is one of the best universities in engineering in Europe. Then we also have this Professor Lee. He's now the chair of ECE department in University of Alberta in Canada, which is again a top university in North America. Then we also have alumni who are doing very well in industry. So this Dr. Hu founded a startup company, Synergy, and they received over 10 million investment from VCs. They developed a wireless charging system for mobile robots. Then this Dr. Jin is a senior manager with Masida, which is from a company from Middle East, Abu Dhabi, I believe. Yeah. So the guy is now managing billion-dollar energy storage related project. Then we for the scholarships available for international students, the most prestigious ones, these are Nanyang President Graduate Scholarships. So basically, every month, for international student, they will be getting 4,300 Singapore dollars. So if we convert this into US dollar, it's about 3,300 US dollars, which is sufficient, for you to have a very decent life in Singapore. Then on top of that, the scholarship also provide conference travel allowance, so you can attend international conferences all over the world, and other allowances to support the PhD research. But this scholarship is very, very competitive. So you have students have to compete with applicants from all over the world. They really have to be the best among their cohort for application. Then we also have another one, NTU Research Scholarships. So this is also open to international students, and the monthly stipend is 3,000. So you divide it by 1.3, that would be the amount in US dollars. So again, I would say this is sufficient if you want to have a decent life in Singapore. Then the students do not need to pay tuition fee. It's already covered by the scholarship, and also for this NPGS, Nanyang President Graduate Scholarship, students do not need to pay tuition fee. Then this one is not relevant. It's more for local students who are Singaporeans or PRs. Then this is another program, interdisciplinary graduate program, uh, which means that the research itself is involves this cross-disciplinary research. So student will have two supervisors, one from different schools. For example, one could from electrical engineering school, the other one from computer science or chemistry. So the idea is to promote cross-disciplinary research collaboration to produce more impactful research outcome. So that's the intention of this PhD program. Then in terms of stipend, tuition fee, these are all the same as these NTU research scholarships. Yeah. So every year we have two intakes, one in August, one in January. So the next round would be August 2026 intake. Then the actually now the application is open until I would say next end of next January or latest February or March. So yeah, you can find more information from here. Then later I will share the slides with Prof. Hector. Then you can see more detailed information. Yeah, I think that's all. That's all for my presentation. So again, thank you very much for having me today. And I look forward to your questions and comments and see how we can collaborate in the future. Yeah, thank you.
Thank you, Jim. Amigos, amigas, tenemos pues que $1 americano es 1.3 dólares de Singapur. ¿Ya? Entonces, $1 americano es 1.3 dólares en Singapur. Luego, en el chat, si ustedes pueden ver, se ha compartido los enlaces de la universidad, como también de las facultades o los colleges, también de su área de investigación, los centros de investigación de excelencia, así como propiamente el área de G, que es el centro de investigación al cual el profesor Tan pertenece, también se ha compartido por el chat. Finalmente, se ha compartido el tema del scholarship, ¿no? Del scholarship en Nanyang para su ¿no? revisión. G, yes, there are distance between Lima and Singapore, but at the same time, the topic, the renewable energy is the key issue in 21st century.
Yeah.
The people know, no? Yeah. Singapore, 5% the energy is the renewable energy. So this is a challenge for Singapore. The people know about the agreement between Malaysia and Singapore. In seminar, some professors de Malaya University participated in our seminar before pandemic. So in Peru, we have the embassy, the Indonesia and Malaysia. The embassy Indonesia developed a program, the free program, the Bahasa Indonesia. So the Southeast Asia is very active in Lima to promote the Southeast Asia higher education and different activities. So yes, we are a distant country, but at the same time, there are some Southeast Asia countries with work, with projection to South America in this year.
Yeah.
So we can project a similar activity in Singapore. So in this area, the renewable energy in the seminar this year, the professor Dominic Mois de Dresden, and Professor Jose Torre from Ecuador, but he worked in Delft University in Holland. They share the experience in renewable energy in Germany and Netherlands, Germany and Holland. In Germany, in early 21st century, the Germany university enterprise and Germany state has a big projection, no? A big future with renewable energy. But after 25 years, it's different. It's very difficult, the renewable energy in Germany. Even the public policy to develop to support the renewable energy. In Netherlands, the Delft University has a project, there's 20 and 30 years, to connect with the sea, no? The sea, the energy, the marine sea, to the coast. It's very attractive, this project. So, Singapore is a small country, yes, of course. We can read about the natural gas for the Singapore. So, in your experience, in your projection, really, what could be these initiatives with Malaysia and Singapore could be very important for develop the renewable energy in Singapore? What is your idea, your projection with the renewable energy in your country?
Oh, I see. Okay, yeah, the government is pushing for this. So, there's a target to achieve 2 gigawatt generation from solar by 2030. So 2 gigawatt is like so the entire country requires a peak load demand of 8 gigawatts. So that's about 1/4 of that. But still, Singapore is too small to deploy enough solar generation. Then there are plans to import clean energy from neighboring countries, from Indonesia, from Thailand, but these are still in discussion. Yeah. Then other solutions, I know that the government is also investigating nuclear energy, but I would say that there are a lot of concerns. It's like a very long-term plan. Only until the technology matures, it's 100% safe for Singapore. Then, it's more of a long-term energy transition plan. Yeah.
Well,
yeah.
I would like to introduce Janina. ¿Me escuchas, Janina?
Yes.
Yes, it's a graduate from Industrial Engineering Faculty.
Yeah.
Janina, ¿puedes compartir tu pregunta, tu consulta?
Well, I would like to introduce myself first. My name is Janina, and I'm a engineer. I will keep talking about my research for this industry 4.0. And well, I'm also very interested in pursuing a master program in artificial intelligence.
Please, Janina, can you write? ¿Puedes escribir tu pregunta? El audio está muy bajo.
Okay.
Gracias. Rosian, ¿me escuchas?
Yes.
Rosian es una destacada graduada de Ingeniería Industrial, de Industrial Engineering from my university. Rosian, ¿puedes compartir tu comentario, tu pregunta?
Oh, for me, yes, of course. Well, according to your presentation, I understood that you can share some information with our university.
Sure.
So my question is, why did you decide to start sharing that with San Marcos University?
You're saying the research part or the
Yeah, the research, yeah.
Oh, research part. Why I share the research part? Oh.
So are you interested sharing that with industrial engineering as I know that many faculties can have that information, but
Yeah.
why did you decide to share that with our university? And
Well,
in which way do you think San Marcos University can also share with you some information?
oh, I see, I see. Because you see that we work in the in academia, so I believe uh, academics we exchange knowledge, right? We will share our research outcomes, and we hope that the researchers working on the same area, they can, they can cite your work. So I'm always open to sharing my research to other researchers. Yeah. Then in terms of any information from your university, I would say that in the last part of my presentation, I shared about these PhD opportunities in our school. I would say that's one of the potential ways to connect the two universities in terms of collaboration, research, training of talents. Yeah. So that's the idea of this giving this presentation. Yeah.
Okay, great. So, what about our, we have different kinds of artificial intelligence, right?
Mm,
So, in
mm,
which one would you like to improve our university? In which area would you like to improve it?
my university or
Yeah, your university in
artificial
union
intelligence?
with Marcos, yes, about artificial intelligence.
Yeah, yeah. Actually, we have a very strong group in our school, and beyond that, we let me show again my screen. We have another college here, CCDS, College of Computing and Data Science. So this is a new college just founded last year, and this is in response to the booming of AI and machine learning technologies. So government Singapore government is investing a lot of money in this area, AI, machine learning. Many they offer like scholarships, internships, many job vacancies in Singapore. Yeah.
Yeah, amazing. That's
Mm.
great.
Yeah. Yeah. Thank you.
You're welcome. Thank you so much.
Gracias, Rosian. Gracias. G, I would like to introduce Milton. Milton is a graduate from engineering electronics from San Marcos University.
Yeah.
Milton takes 1 year in Hanyang, in Seoul, Hanyang University in Seoul. Milton, ¿nos escuchas?
Sí, ¿qué tal? Buenas noches con todos.
Sí, please.
Sure. Thanks for sharing your research, Professor Tan. That
Yeah,
was
you're
very
welcome.
interesting. Well, a brief introduction about me. My name is Milton Rios. I'm an electronic engineer's bachelor's graduate from San Marcos University. And now I am interested in pursuing a master or PhD degree at NTU. Well, I've completed my undergraduate degrees in electronic engineer, and now I'm conducting an independent research thesis in graph neural networks for medical morbidity predictions. Some of my backgrounds combines electrical engineer fundamentals with some practical machine learning experience, like deep learning applications across
Yeah.
multiple domains,
Yeah.
and also an international research experience in South Korea.
I see.
About your presentation, I'm very particularly interested in information engineering research areas within EE. Especially, I think that it was an artificial intelligence sub area.
Yeah. Yeah.
Yes. I would greatly appreciate if any guidance or potential research opportunities
Yeah.
about
Sure.
pathways for joining at graduate programs in NTU.
Yeah. 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 No problem. I actually we have a list of the funded PhD project available in our school. So later,
Okay.
after this seminar, I will share the list as well as my presentation slides with Professor Hepler. Then yeah, I believe you will see more detailed information, like the
Oh,
project,
oh,
yeah, project related
okay.
to your research interest. Yeah.
Okay, and some
Mm,
brief questions about is, do you think that it is necessary
mm.
to talk earlier to the professor
Yes.
before to apply for an
Yeah.
admission in
Yeah.
that programs?
Yeah. That would be helpful. Yes. Mm,
Okay.
yeah.
Oh, okay, okay. Thank you so
Yeah.
much.
Yeah, you're welcome. Then another thing is that I learned from another student from your university that your undergraduate courses are taught in Spanish. No, I'm not sure if my understanding is correct or not. Uh, it's not in English, right?
Sorry. Could you repeat, please?
I mean, your undergraduate courses, the courses are taught in Spanish, not in English, is it?
Y- Yeah, absolutely. Yes.
Yeah, then in that case, you also need to have like in English test scores like from TOEFL, IELTS, and GRE. This is part of the application requirement. I mean PhD application requirement.
Oh, okay. Thank you.
Yeah. Welcome. Yeah.
Yeah. Jim, you can read, please, the chat. Is the question the Janina?
Oh yes. Project. Are there any research initiatives, pilot program, education models could be adapted in Peru? Wow. Well, this question is Peru because for me, to be honest, I'm not very familiar with the education and the research ecosystem in Peru. So maybe I just share from Singapore perspective. Pilot program research initiatives. Well, I would say that for Singapore, one of the strengths is that the university really encourages us to work with industries. So we are not just publishing research papers. We also hope to see that our output can be adopted by companies. So you see the project I presented just now, the aircraft, the energy storage project. It's not the lab scale research. After publishing research papers, then nothing else. We really deploy the system in real world application. So this is the things I enjoy very much as a faculty member in NTU. Then other things, educational models. Mm, educational models. I mean, this is the topic is too big. I'm trying to come up with something specific, which we have bachelor's degree, master's degree, PhD's degree programs, which are each of them, I would say, quite different. The training of the student is quite different. I'm not sure whether this, to some extent, can answer your question.
Well, gracias, Janina. Jim, amigos, amigas, tenemos pues que Nicole Caballero, graduada de Ingeniería Biomédica, becada Erasmus, terminó el máster en Grenoble, va a iniciar en Loughborough, norte de Inglaterra, su doctorado. Ella es parte de una red internacional de estudiantes de ingeniería, entonces hizo un congreso ahora recientemente en Singapur y Nicole se reunió con Jean justamente días pasados. En Nanyang se hizo presente, ¿no? La proyección, ¿no? El interés institucional el profesor Ian Chow, que es el manager regional para las Américas de la universidad, Gao Weibo, que es el director de la Escuela de Ingeniería Eléctrica Electrónica de Nanyang. Justamente el profesor Gao sugirió, ¿no?, que el profesor Tan pudiese dar la charla que hemos asistido ahora. Entonces, el director de la Escuela de Electrónica y Eléctrica en Nanyang está atento a esta actividad, así como Warren Chan, que es el decano del Colegio de Ingeniería o Facultad de Ingeniería en Nanyang, aparte del profesor Zhou Cheung, director del Chinese Heritage Center, y el profesor Liu Hong. Entonces, hay varios colegas en Nanyang que sí están atentos a esta actividad. Hay una gran distancia entre Singapur y Lima, pero Jim, St. Mark University has many places, the principal place in the capital, but we have a place in Chilca. Chilca, 2 hours south of Lima, is near the thermoelectric. Lima, the energy capital of Peru, is from Chilca. So it's a big opportunity to research about the energy, design, planning with university, your area, your academic area.
That would be great.
I believe, yes, it's very distant, it's very different culture, okay, but can imagine we can think could be possible. You can connect with our research in doctoral school about your topic in electrical.
Yeah.
Yes, yes, of course. So I would like to invite you to Lima. Here I can host you 3 days in Lima, so we can continue.
Sure.
We have time. We have time. Your university is very young. Singapore in 21st century, I'm sure, will increase contact with South America. In this moment, the Global South start a new dialogue with the North. You can see Brazil, you can see Indonesia, 20 big economy in the world. So it's a time for the South. South America, in this moment, especially in Peru, with the Chinese there are north of Lima, 3 hours north of Lima, and megaport Chancay. This port will increase trade with the China, and Peru is similar to a bridge between China and Brazil.
I see.
So for any countries, the activities with Peru, at the same time, activities with Brazil. The seminar has some activities with the Sao Paulo University. Now, this year, last October, in the Politécnico, in Sao Paulo University, the College de Ingeniería Politécnico, the new director of the Politécnico is a professor de electric engineering.
Okay. Yeah.
So we can, the last month, some students from electronic engineering take research visit to Sao Paulo University. So we can project this Sao Paulo University, San Marcos University, engineering, electric and electronical could be this experience, could be interested for the Nanyang, Singapore.
Sure.
Nanyang Technology, Singapore. Yes, there are distant, how many hours? I remember it's 20 hours, but
yeah, 30 hours, yeah, probably.
Singapore to South Korea, South Korea to California, California to Lima. It's all could be the Singapore to Sydney, Sydney to Santiago, Chile, and Santiago to Lima. Yes, 20 hours. But probably Singapore is sinking to the South America, to Brazil, and next to Brazil, Peru. Peru is the connection of Brazil to Pacific. So is Pacific, Peru, and Brazil.
Yeah.
So in economics and academics engineering, it's more probably this contact, this is change in the future.
Yeah, sure.
So
Yeah.
I would like to continue this experience. I would like to invite you to Lima. I sure your experience could be very important for our professor, our student. And so your university, Peru and Singapore has a common heritage. What? Yes. In 19th century, 150,000 Cantonese traveled to Peru in middle 19th century. So now the 10% the Peruvian population has Chinese origins.
Oh.
The people know the big Chinese tradition in Singapore, no? 80%, no? In Singapore.
Yeah.
In Peru, we have 10% of our population has Chinese, really Cantonese
Okay.
origin. So this is we can find some common connection between Singapore and Lima, especially the central coast of Peru.
Yeah.
Your family from South of China, the Tang.
Yeah, for me, I'm originally from China.
Okay.
Yeah.
Yes. At the same time, Sangmar University has activities with the Fudan University in Shanghai.
Oh, that's a top one in China.
The last month, Jiyan Chen is director of the Spanish department in Fudan. Shared research about the trade between the China, Philippines, and Mexico and Peru in early modern history. So we had contact with the Fudan, the Sao Paulo, and now with Nanyang. Could be for Nanyang interested in this experience with the Fudan and Sao Paulo University.
Yeah. We stay in touch for sure and see how we can better collaborate in the future.
Yes. Amigos, amigas, ¿tienen algún comentario, alguna pregunta, por favor?
So now it's 9 p.m. in the evening in Lima.
It's the night. It's the night in Lima.
Thank you for staying so late with me.
I with Fudan University in the last year, we have a program with the total student, the San Mark and student, the Spanish department, the Fudan, and the meeting in the night in Lima and the mornings Shanghai. Yes, this hour is no. We had some experience before.
Okay.
With the Seoul, some professor when Seoul and Busan shared experience in the nights, the Lima to the morning, the Busan.
Yeah, I understand.
Well, Jim, in your school, what is in this moment the people project the electric cars, no? The electric automobile.
Yes.
At the same time, the intelligence, artificial intelligence, autonomous vehicle. So in this area, how develop this area in your university and Singapore?
Yes. Government is also pushing for electric vehicles. It's not at the pace as China. China is adopting new technology really fast. For Singapore, the government is taking it step by step. But right now, the EVs, I mean, in terms of sales every month, is number one in Singapore. The problem is the charging infrastructure here many of the car parks, they are not equipped with charging points, especially when you require fast charging, supercharging. The infrastructure, I mean the power grid, is not really designed in the past to support such high power fast charging. So that's why the EV fleet is increasing slowly. I don't have the figure like how many percent are EVs, but it's climbing up, EV in Singapore. Yeah.
In 28th March, Professor Yu Jin, the Changwon National University, South Korea,
Yep.
she is the chief the
Mm.
laboratory the robots and instrumental engineering.
Yeah.
She shared his experience about the Changwon. Changwon is a city near Busan. It's a very interesting the South Korean state to develop the autonomous vehicle.
Yeah.
In this moment, the people see we can live a transitional age in energy and transitional age in politics and the trade, no? So, in 20th century, the Atlantic very important, the Atlantic trades, but now the Pacific trade. In 20th century, we can see the United Kingdom and America, strong countries, strong in the geopolitics. Now we can see another countries. In energy, in 20th century, the oil, the natural gas. In 21st century, we can see the renewable energy.
Right.
So in this moment, we live this transitional age. But in your projection, when finish this transition and start this a new energy age, what is your feeling about that? In this moment, very important, the oil, the natural gas, the states support the renewable energy. Okay.
Yeah.
The projection is the renewable energy will be the principal energy. This is an idea, no? This is a projection. But how many really do you believe this transitional, or you believe all 21st century is a transitional age?
Understand.
Or you believe no, it's 20 years. What is your?
Understand. Yeah, thank you. It's a big question. I think governments around the globe, they set targets. Like in the context of Singapore, it is aimed to achieve we call carbon net zero carbon emission by 2050, if I remember correctly. Then in the context of China, they define two time frames by, I can't remember exactly. The first one is to achieve carbon peak, which means that in the following year, the carbon emission will be coming down. That should be 2040, or I can't remember correctly. So exactly, sorry. Then another target is to achieve net zero, which means that the carbon emitted to the ambient should be offset by the carbon absorbed by environment or other technologies. They should achieve a balance. That's what we call carbon net zero. That is 2060, 26. 60. Yeah, so these are the target set by the government.
Jim, in your university, the energy, your university use natural gas or use renewable energy? In Nanya.
Well, I would say majority of the power supply is still from natural gas, but we do have. I've shown on one of the. Let me show again. So you can see here, we also have rooftop solar generation. So the whole campus can produce 10 megawatt peak power. So I don't know how much it is in terms of the percentage of the power consumption of the entire campus, probably 5% or 10%. Yeah, the constraint is the land. We don't have space to install solar panels. So you know that in Singapore, we also explore we call floating solar, which means that the solar panels are installed on the reservoir, water reservoir, because we don't have enough land space here. Yeah. And also, the government is studying energy import, clean energy import from neighboring country because they have the space, right? They can install solar and wind turbines. Then through transmission lines, we can import the clean energy. Yeah.
In many society, the 20th century, the engineering was a masculine profession. So in 21st century, the challenge for the society is increased contact connection between the women and engineering. The women's and engineering. In Singapore experience, this is different between the 20th century, 21st century, or is similar?
So, Prof, you are talking about the challenges to engage more female researchers, engineers in engineering studies. Is that the question?
Yes.
I see. Yeah, I think we are facing the same issue. If you look at the student population, the male student is much more than female student. I would say for our undergraduate student, probably 4:1. The ratio is 4:1. But if you look at the PhD student, and even the faculty member, the female faculty members are much less than male faculty members. Then what we could do is that we provided more opportunities to engage women in engineering. So, for example, if you attend the international conferences, at least for my research area, there are always a session dedicated to the topic of women in engineering. To engage, to promote more female students to study and to participate in engineering research. Then at the school level, we are also organizing similar activities to engage our female student. Hopefully, we can improve the ratio of female researchers. Yeah.
Well, amigos, amigas, por favor, ¿pueden prender sus cámaras para tomar una captura de la sesión, por favor? Pueden dejar todos también su correo electrónico en el chat para que se ingrese su asistencia. si pueden dejar todo su correo electrónico en el chat, así se ingresa a su asistencia. Por favor, pueden prender su cámara para tomar una captura con el profesor Tan. Please, G, we have take a picture. Wait a moment.
Okay, okay.
¿Pueden prender todo su cámara un momento, por favor? Uno, dos. Un momento. Uno, dos. Bien, muchas gracias. Celia, Janina, Omar, Augusto, muchas gracias a todos. G, thank you very much.
Yeah.
Yes,
Yeah.
we're distant country, but at the same time, we have common heritage,
Sure.
Chinese, Chinese heritage.
Yeah.
Well,
Thank
I
you
hope
very
that
much. Yeah, for organizing this seminar and for inviting me.
I hope that you can visit Lima in the future.
Yeah,
We have time to develop more activities.
Sure.
Well, amigos, amigas, les hago presente este día jueves en la tarde tenemos la presencia del Instituto de Matemática y Estadística de Sao Paulo University. El profesor André Fujita va a compartir su investigación sobre bioestadística. Este día jueves a las 2:30 de la tarde nos acompaña la Universidad de Sao Paulo, Instituto de Matemática y Estadística. Thank you very much, Jim. Muchas gracias a todos y estamos en contacto.
Yeah, we keep in touch. Yeah, I will share the slides. Yeah.
Yeah, thank you.
Thank you.
Envíen todo su correo al chat. Muchas gracias.
Yeah. Thank you. Bye bye.
En Singapur son 9 de la mañana, así que bueno, fue el momento que pudo conectarse Singapur con Lima. No se olviden, por favor, su correo electrónico todos. Muchas gracias. Muchas gracias.